wind head-on. Tests reveal that even this building, at only half the size of Sky City, could be in jeopardy.
We determined that the wind loads that were on the building were higher than what they expected.
Suddenly, the entire project was at risk. It was a devastating blow. Until engineers devised a simple and elegant solution. By reconfiguring the corners of the building to a cutout W shape, the force of the wind could be deflected. But Sky City's designers face an even greater challenge because it presents an even larger target. The solution? Make the building round, allowing ferocious high-altitude winds to slip right past it. But wind can cause still one more problem that simple streamlining can't solve. Skyscrapers sway back and forth, even in a light breeze. Unchecked, the motion can make inhabitants seasick. As these test subjects riding a skyscraper simulator can attest. How could Sky City's designers stop their titanic tower from tossing like a ship in heavy seas? In smaller buildings, engineers often install heavy counterweights to counteract swaying. In Taiwan, builders plan to hang a steel sphere weighing an incredible 1.3 million pounds. When wind pushes the tower one way, the weight will move in the opposite direction, counteracting or damping the building's movement. But the larger the building, the heavier the weight must be to steady it. And in a building as massive as Sky City, a counterweight would have to weigh as much as 50 million pounds. It would monopolize an entire space plateau. Real estate too valuable to fill with dead weight. Can anything take its place? Scientists at the Takanaka Research Institute are working on a solution. They're shaking things up in the world of mass dampers in a state-of-the-art test facility simulating earthquakes and ultra-high winds. This 5-story building's been modified to wobble like a 30-story skyscraper in a hurricane. Rubber separators between the floors make the building unstable, creating an ideal test bed for Takanaka's radical new wind damper technology. Located on the top floor, this 6-ton weight can bring the swaying building under control. When sensors detect sway, a computer directs 2 powerful hydraulic pistons to shift the damper in the opposite direction. Because this system is powered, this active damper can be smaller and lighter than a passive or unpowered damper would need to be. Rescuing valuable real estate at the top of a building. Making Sky City both a safe and gentle giant. Easy on the stomach. With the last structural problem solved, Sky City can now take on the challenges that confront every other modern city. Tokyo suffers from some of the worst traffic congestion in the world. One of Sky City's goals is to offer freedom from the tyranny of autos.
Developing the right traffic system and the system for delivering goods throughout the city will be a very important task.
During rush hour in Sky City, as many as 100,000 people could be on the move inside the tower. To find a way to move people efficiently, designers looked to the past, to the work of legendary architect Frank Lloyd Wright half a century ago. In 1956, he proposed building Mile High City. At 528 floors, the structure would have been much taller even than Sky City. And Wright proposed radical new technologies to help people get around, like multi-decker atomic-powered elevators, cruising at 60 miles an hour, and landing pads for 150 personal helicopters. The building was before its time. But Wright believed that one day, buildings like this would be commonplace. That day may have finally arrived. Atomic lifts are not an option, but engineers are working on systems that would make Wright proud. With enough speed and capacity to keep Sky City residents on the move, horizontally and vertically. This is the Otis Elevator Testing Tower near Tokyo, the tallest elevator test site in the world.
In a high-rise building, the biggest question is how to make the elevators work to carry the greatest number of people in the least amount of time.
Otis engineers have built one of the fastest elevators in the world, able to cruise at over 30 miles an hour. They've also perfected a double-decker elevator system that can carry 70 people at once. It's a good start, but for Sky City, they know that they'll have to do even better.
Sky City will be 1,000 meters tall. If you use a normal rope-based system, the elevator weight becomes really large. So we'll have to improve the technology to lighten the rope or to find a way to eliminate the rope completely. That's the goal.
Combining the next generation of elevator technology with computer-driven high-speed trains, engineers will create an elegant three-ring circus of transportation. A visitor to the building could take a triple-decker elevator from the ground to the top in just over 2 minutes. Or climb the tower's exterior in a spiral monorail. Perhaps shuttle on a local elevator. Or circle one of Sky City's parks in a Skywagon. The days of time-wasting commutes would be over. By condensing the entire sprawling city into one enormous vertical tower. But the bigger they are, the harder they fall. And Sky City's designers are preparing for the worst killer that can strike a skyscraper. Fire. For high-rise residents, there's nothing more terrifying than this. Tokyo has one of the finest fire departments in the world, battle-tested not only by fires, but devastating earthquakes, typhoons, and other natural disasters. When the alarm sounds in a skyscraper, firefighters jump into action, but not in trucks.